today I have been diving deeper into foundations, closing my skills gap, and so I spent a lot of time on memory. At least in the LangGraph world, they have a graph. It's a series of workflows, if you remember nodes and edges that they connect. One challenge, especially for conversational agents, is this idea of memory, which is saving the information. So when you talk, when you interact with the agent, it actually remembers the conversation. You're not entering into a new conversation every time. For the agents that I build, because they tend to be more ambient agents for my workflows or single turn, trigger, do this, I haven't had to think a lot about memory as a concept and dive into those foundations. But because I am closing the skills gap, did that today because it's pretty foundational. So in the LangGraph world, wanted to go over a few different things that I learned around how memory works. So LangGraph has a pre-built utility called checkpointer. And how it works is after every node runs, a checkpoint will then save that piece of the memory, save it into memory. Then you can get a little bit more fancy with it. And there are options to update the state schema so you can tell it what exactly to save. Use a reducer if you want to not just save and overwrite kind of each step, but after each step, but also add to it, and some even more interesting workflows around summarization. So, one thing that gets complicated with memory is context windows. Each AI typically has a context window, and the longer your conversation back and forth, the more context with memory. I learned about a new system around context compression, which is basically you take a set number of turns, pieces of memory, and you just summarize it as opposed to appending into oblivion. And then there are pieces where you can save either memory externally to a database or keep it internally. And as I think about how these concepts might apply, again, I'm doing mostly single turn conversations. But there might be ways in which this can help the system be a little bit more self learning, self improving. If I save into memory maybe the outputs or the iterations that I've made to the model, then the next turn it could maybe use that context to do better on the next task. Not sure how it all works out, but I'm layering more just like less vibes and more deep knowledge onto how these systems work. And that's it for my update for today.